Hello, welcome back to this AP Statistics Aligned lesson. Today we're going to continue our discussion of quantitative data, and we're going to be mainly creating a 5-number summary and then a box plot. Along the way, we'll be talking about outliers and skewness. So let's get started. To make this lesson relevant and interesting, we'll use a data set on the number of text messages sent by students in a day. In today's digital age, texting is a significant part of communication, making it a relatable example. Here's a data set representing the text messages sent by 20 students in a day, from 2 to 120. This data set is already ordered from least to the most text messages. Remember, if you need to find the median by hand, you must order the data from least to greatest. First, let's calculate the measures of center, the mean and the median. We'll calculate the mean first. The formula for the mean is available in the AP Statistics formula sheet, but it looks a little strange. It gives you this formula: 1 over n times this symbol, which is a capital sigma, and then it has this xi and n thing. But what it means is the summation formula, this capital sigma, means to add up all of your data values. And then the 1 over n means to divide it by however many observations you have. So it is our typical way that we calculate the mean or the average. We add up all of the values in our data, and then we divide by the number of data points that we have. So in this case, we're going to add our 2 and our 5 and our 5 and our 8 and all the way up to 120, and then we'll divide by 20, the number of students in our data sample, and we get a mean of 33.9. Next, we'll find the median. Since we have an even number of observations, 20, the median will be the average of the 10th and 11th values. Those are 25 and 28. So we add them together and we divide by 2. When we do this, we get a median value of 26.5. The mean is larger than the median. Do you wonder why this difference exists? We'll explore this later in the video.
Bro, what is it? Dude, I just don't get it. My friend's so middle. He never has an opinion for anything.
What's his name?
Median.
Now let's calculate the 5-number summary, the interquartile range, which we simplified to call IQR, and the range. The 5-number summary includes the minimum, Q1, medium, Q3, and the maximum. What I like to do is list them out from least to greatest. So the minimum is 2. We can see this easily in our ordered data set. Q1 we'll come back to. The median is the middle value, and that we found already is 26.5. Q3 we'll come back to, and the maximum we can also see easily in our data set. The Q1 value is the median of the lower half of the data. So that is the data from 2 to 25. There are 10 data points in this value, so when we go 5 up from the bottom and 5 down from 25, we get 10 and 12. So we find the average of these two values. 10 plus 12 is 22, and 22 divided by 2 is 11. So Q1 is 11. Similarly, for Q3, we're going to look for the median of the upper half of our data. So we're going to go 5 up, including 28. So 28, 30, 35, 40, 45. We get to 45. That's one of our values. And then we calculate 5 down from our top, and we get to 50. So we average the 45 and the 50, and we get the Q3 as 47.5. So now we have found all 5 of our 5-number statistics. The range we have found before. That is just the maximum minus the minimum. So we have the highest number of text messages as 120, the lowest as 2. So the difference in the maximum minus the minimum is 118. There are 118 text message differences from the one who posts the most to the one who posts the least. The interquartile range is the difference between Q3 and Q1. It's the middle half of our data. So the IQR in this example is equal to Q3 minus Q1, or 47.5 minus 11, or 36.5 text messages.
You calculate the spread?
Yes.
And what did it cost?
Half the data.
When we are looking for outliers, we're going to use the AP Statistics definition, which is to look for 1.5 times the IQR difference from our Q1 and our Q3. So we have an upper and a lower bound. Our lower bound for a low outlier is our Q1 value minus 1.5 times our IQR value. In this particular case, we have a Q1 of 11. We multiply that times 1.5 times 36.5, our IQR value, and we get 11 minus 54.75, or negative 43.75, as our lower bound. This makes no sense, since we cannot send a negative amount of text messages, so we won't have to worry about any lower bound outliers. To calculate the upper bound, it's Q3 plus 1.5 times the IQR, so 47.5 plus 1.5 times 36.5, which gives us 102.25 text messages. So we do have one upper level outlier, the person who sent 120 text messages. When comparing the mean and the median, the skewness of the data tells us a lot. If the mean is significantly greater than the median, the data is considered right skewed. The high values in the data are pulling the mean to the right of the median. If the mean is considerably less than the median, it's considered left skewed. The low values are pulling the mean to the left of the median. Our dataset has a mean of 33.9 and a median of 26.5, indicating it's right skewed. We'll see this visually when we plot the data.
If my data distribution is skewed, what does it mean?
It means your data is not normal.
Oh, how often does that happen?
It's normal.
Finally, let's create a box plot to visualize our 5-number summary and outliers. When I'm creating a box plot, I first like to plot any outliers with a dot or an asterisk. Then I plot the next most minimum and maximum values with little vertical lines. I like to draw then a horizontal line from the barred values, the minimum and the maximum barred values. Then I draw little vertical lines at Q1, median, and Q3 and connect them to form the box. The box plot gives us a lot of information. It breaks down the data into quartiles or percentiles so that it will show where different percentages of the data lie. In our example, 25% of the data is at 11 text messages per day or below. 50% of our data is at 26.5 text messages or below. 75% of our data is at 47.5 text messages or below. And 100% of our data is at 120 text messages or below. The interquartile range, the IQR, is the shaded region, the box, the whole box. We can see the range. The maximum and the minimum are plotted. 120, even though it's an outlier, is still the maximum. We can see the skewness of the distribution of this data set because the upper half of the data is a lot wider than the lower half of the data set. We can create a SOC-V interpretation and context for this data set. We could say the data distribution of student text messages per day is skewed to the right. There's one outlier of 120 text messages per day sent by one student. The median text messages per day is 26.5, and we have an IQR of 36.5 text messages per day. Understanding the context is crucial. This data might reflect varying social behaviors, communication preferences, and even differences in technology usage amongst students. By implementing the data within this context, we can gain deeper insights into student behavior and make more informed conclusions. To summarize, today we covered how to calculate the mean and median, determine the 5-number summary, IQR, range, percentiles, identifying outliers, and creating box plots. We did a lot today. We also discussed the relationship between the mean and the median in context of data skewness. Remember, interpreting data within its context helps us understand the narrative behind the numbers. Our data set on the numbers of text messages sent by students provides a great example of right-skewed data and how to visualize and analyze it effectively. Thank you for joining me today. Don't forget to like, subscribe, and hit the bell icon for more AP Statistics Aligned lessons. Stay curious, keep questioning, and remember, data isn't just the numbers. It's a reflection of the world around us.